Welcome guys to today's class. In today's video, we want to look into another important experiment in practical physics, and that is experiment on horizontal vibrating rule. So if this is the first time of coming across our video, yes, you will surely enjoy our video. So do well to click subscribe, click like button, comment, share to your classmates and friends so that they will learn as well with you. Okay, what is the aim of this experiment or objective of this experiment? To determine the relationship between the periodic time t and the length L of a bipolar suspension of a half-meter rule. That means at the end of this experiment, we'll be able to see the relationship between time and length, so to speak. Then the apparatus, half-meter rule, thread, two stands and clamps, and stopwatch. Let's go to the method or procedure. Suspend a half-meter rule horizontally with a graduated face up by a pair of vertical threads of length L equals to 80 cm. Each attach 5 cm from the end of the rule. Displace the ends of the rule through an angle theta and release the rule to perform angular oscillations in horizontal plane about a vertical axis through the center of the rule. Measure time for 10 oscillations. Repeat the experiment for L equal to 70 cm, 60 cm, 50 cm, 40 cm, 30 and 20 cm. So this is the apparatus setup of this experiment, where you have thread, the rotor stand, the meter rule, the angle of displacement. Yes. Now, it is important to note that this experiment, so to speak, obeys all the principles of what? Simple pendulum. In simple pendulum, we have a lot of formulas there. And one of such formulas we have is that period is equal to 2 pi root L over G. We also have period equals to 2 pi root M over K and others. Let's talk about this one especially. Do you know that we can rearrange this to get a lot of things here? Take for instance, when you write T from law of indices is equal to 2 pi root what? L all over root what? G. Do you know that what you are having here, let's package it well, root G. Do you know that this simply means T equals to 2 pi, root L means L raised to power 1 over 2, all over, then carry this root G, bring it here, root what? G. And do you also know that this means T equals to 2 pi over root G. We'll replace it with what? K raised to power 1 over 2. Where K is equals to 2 pi over root G. 2 pi over root G. Please note this concept very well. This is trying to tell you that this 1 over 2 is constant and this K is constant. Are you getting it? And so, I will use this formula now to make these my tables without performing this experiment. Yes. How do I do that? 1 over 2 is constant already and K is 2 pi over root G. Note that the value of G you will be taking should be ranging between 960 to 980. Please make use of this value, centimeter per second square. Let's write it clearly. The value of G is total to be 980 centimeter per second square. But the one you will be using in these your manipulations is to range from what? 960 to what? 980 centimeter per second square. Please don't forget this information. The reason is because if you use 960 in this, after your approximation, it can get to 980. If you use 970, after your approximation, you can get to 980. So, me, I prefer I recommend students to use either 960 or 970 instead of that 980, so that after approximation everything will be falling down on 980 centimeter per second square. And so let's take 970, because I said use either 960 or 970. You will be having 2 pi all over root what? 970. So 2 pi all over root 970 should give you what? 2 shift pi divided by root 970. That will give you 0.202. That means our care is equal to 0.202. Okay? Now, this unit of your care, you know that when you have this as a constant, so to speak, now that is what you will use to do your what? Your table, or to make your table. We are saying in essence that as you have t equals to 2 pi root L all over root G, root L all over root G, we are saying that your k is equals to 2 pi over root G, and the power of L, which is n, equals to what? 1 over 2, or 0.5. We say note this. Then we are now saying that when you check for k, unit of k should be in seconds. Unit of k should be in seconds. Yes, because after the calculations are done, it will leave you in seconds. Okay, so 1 over 2 will have no unit, so to speak. It has no unit. Then, after you have achieved this your k, the implication is that you should just come and say t equals to, instead of writing k, 0.202, which is 2 pi over root g, times what? Square root of, or times what? What is your L? 80 raised to power of what? 0.5. 0.5 means 1 over 2. That is the power. That is where we got it from square root. This square root sign. Square root L mean raised by 1 over 2. That is what we are saying. So that 1 over 2 is what we are saying, 0.5. So I will be pressing my calculator. 0.202 times 80 raised to power of 0.5. That will be giving me 1.81. I'll write it under the capital T. 1.81 approximately. Like, put it in 2 decimal place, so to speak. You do the one of 70 by cleaning this 80 and replace it with what? 70. Okay? We don't want to perform the experiment, so that is why we are doing it this way. Times 70 raised to the power of 0.5. 1.69. 1.69. Wow. Then we go again. Replace this with 60. 0.202 times 60 raised to the power of 0.5. 1.56. 1.56. We go again. We now say that we replace here with 50. Okay? We'll be having 0.202 times 60, okay, times 50 raised to the power of 0.5. 1.43. Then replace here with 40. So if you replace it with 40, you have 1.28. Replace it with 30, then you have 1.11. Then you replace it with 20. When you replace it with 20, you have 0.90. So we have gotten our period. Yes, without touching apparatus. How can we get your Tm? That is the next. Remember that your T period is equals to mean time all over what? Number of oscillation. And number of oscillation is 10. And therefore, Tm will be equals to n times capital T, where n is equals to 10. So 10 times this will be giving me 18.10, 16.90, 15.60. 10 times this, 14.30, 12.80. 10 times this, 11.10, 9.00. We have gotten the what? Mean time of the oscillation. Then T1 and T2, how can we get it? You say this your T1 is equals to Tm plus 1.00. Then T2 equals to Tm minus 1.00. Please use 1.00 so that it will be a unique number. So this minus 1 will be this plus 1 will be giving me 19.10 minus 1, 17.10. Then this one, 16.90, 15.90. This plus 1 will be giving me 17.90, and this one minus 1 will be giving 15.90. This plus 1, 16.60, minus 1, 14.60. Such that when you add and divide by 2, you get it, because this is gotten by add this 2, divide by 2, you get this. So this one, 15.30, then 13.30. Then this one, 13.80, then 11.80. Then add 1, 12.10, 10.10. Add 1, 10.00, and this will give me what? 8.00. So that means when you do this, add this, divide by 2, add this, divide by 2, you get this. Then we go to our log T table. How do we get our log T table? Get the log of 1.81. Log 1.81, 0.258, 0.258. Log 1.69, 0.228, 0.228. Log 1.56, 0.193. Log 1.43, 0.155. Log 1.28, 0.107. Log 1.11, 0.045. Log 0.90 minus 0.04. Let's write it clearly. This gives minus 0.046. Then we are done with log T. What about log L? Get the log of 80, 70. Log 80, 1.90. Log 70, 1.85. 1.845. Then log 60, 1.778. Log 50, 1.699. Log 40, 1.602. Log 30, 1.477. Log 20, 1.301. 1.301. So this is just how to get your what table of values without what looking at those procedure, performing, and be encountering 1001 errors. With this, you have gotten your what table of values without touching what apparatus. Let's go to the graphical aspect of this experiment. Okay, remember we said this is just with the use of formula method. You can use 960 as your G or 970 as your G for the computation to be done. And when you are done, this n is 1/2 is constant, gotten from what is the value of square root. It means 1/2, that is 0.5. So with that, we have gotten the table of value of this experiment. Let's go into the graphical aspect. So these are the questions we have to answer in this experiment. And question number 1 goes this way. Assume that T and L are related by the equation T equal to ALC, where A and C are constant. Transform the equation by taking log of both sides to obtain log T equal to C log L plus log A. I'll still show you how this transformation is done. Yes. Question 2. Plot a graph of log T against log L. Measure the slope and intercept. Measure the constant C and A. Evaluate the standard error in A and C. Number 6. What aspect of the setup is the constant A likely to depend upon? So we'll have to know what is the constant A. Then we'll now be able to know what aspect of the setup is likely to depend on. Then number 7, what is the unit of A? You see why we say there is need to know what is the constant A. When you know the constant A, you will know the unit of A. If the ratio as given above is valid, yes. Guess any practical application of this setup in nature. Should theta be larger or smaller, and why? Precautions, because I say at the end of every experiment, don't forget to bring in your precautions. Then the last one, our conclusion. In our conclusion, we will likely have to tell them if it is true that the period or the periodic time depends on length, and if it is not true, we'll have a lot to discuss here. Let's see how to do it. Let's go to the graph first of all.